exercise, we're going to take a look at cost allocation. How do we allocate a joint product? And we're going to take a look at also a scenario whether we need to make a decision on whether we should process one of the product lines further. Does it make sense? Does it make economic sense? So let's take a look at a case called Sonimad Sawmills, Inc. So let's call it SSI. So let's look at the question. The question starts with SSI purchases logs from independent timber contractors and process the log into 3 types of lumber product. So the 3 types of lumber products are, you've got the studs, the decorative pieces, and the post. These products are the result of a joint sawmill process that involves removal of barks from the logs, cutting the logs into a workable size, and then cutting the individual products from the log. The joint process results in the following cost. It's $1 million of cost. Okay, and these are the costs associated with the joint cost. Now, the product yields an average sales value on a per item basis from the joint process are as follows. So, based on that joint cost, they were able to produce 75,000 of studs, 5,000 of decorative pieces, and 20,000 units of posts. And these are the selling prices of each. The studs are sold as rough-cut lumber after emerging from the sawmill's operation without further processing. The post requires no further processing beyond the split-off point as well. The decorative pieces must be planned and further sized after emerging from the sawmill. So there's another processing that we need to do for decorative pieces. The additional processing is $10,000 per month and normally results in a loss of 10% of units entering the process. Without this planning and sizing process, there is still an active intermediate market for the unfinished decorative pieces, which the selling price is $60. So let's actually do a diagram to kind of highlight these facts. Because I like to be able to visualize the components or the process and what costs are joint and what are the separable costs. So let's do that here. And then we'll come back to the question. So let's summarize the facts. So we've got a joint cost, and that was for $1 million. Okay, so let me put that as a box. So $1 million joint cost. And we're going to process that into 3 different products. We've got, first of all, the studs. We've got the decorative pieces. Let's call it the raw decorative. And we've got the post. Now we're given that this is 75,000 units. And we're also given that the sales price is $8. I'm going to call it SP. And for the raw, we're going to produce 5,000 units. And the sales price of that one, the raw, is 60. Let me look at this again. It says that the it's $100, right? per unit. Okay, so this is $100 per unit. Actually, no, it says, okay, sorry. It says that without this planning and sizing process, there's still an active intermediate market, and the selling price of the unfinished is $60. So this is actually $60. And the post is how many? We're going to make 20,000 units. And the sales price is $20. Now, we're told that under this circumstance, we're going to actually process additional 100,000, but we're going to lose 10% of it. So we're going to process it further. Into what they called finished decorative pieces. And they sell for $100. But there's also a 10% loss, which means that 5,000 will be 5,000 times 90%. We're only going to produce 4,500 units. So this is the other finished goods. So let me circle that in purple. Okay? So I always like to kind of get my head around what are the different costs. So these are the separable costs. And this is also a separable cost. And of course, the separable costs, only one is processed further. Okay, so let's go back to the question. It says, based on the information given, allocate the joint cost of $1 million using sales value at split off, physical measure, and the NRV method. Let's take a look at those three methods. Okay, so let's do the first one. Sales value at a split off. That's the first method. Okay, so we've got three products. We've got studs, decorative. So let's put down studs is S, and decorative is D, and post is P. Now, what is the output under the sales value at the split off point? So this is the sales value at the split off point. That's the split off from that, right? So the number of units for studs, for S, is 75,000. This is 5,000, and this is 20,000. And the selling price at the split off point is $8.60 and $20. So that's the sales price at the split off point. Okay? So sales value at split off is 8 times 75 is 600,000. And this 60 times 5 is 300,000. And this is 400,000. 1,300,000. Now, what's the relative weight? The weighting is going to be 600 divided by 1.3, which is 46.1539%. 300 divided by 1.3 is 23.069%. And this one is 30.7692%. So joint cost, so JC of 101 million, sorry, is going to be allocated based on this joint cost. So 461, 539, 230, 769, and 307, 692. So that's how we do it, a sales value at the split off point. Now, the NRV, so I'll just do the NRV next because I know it's part C, but let's do NRV. NRV, we're looking at the net realizable value. In this case, the net realizable value for studs is the same as the value of the split off point, and so is the post, but this one is different, isn't it? So we're going to take a look at this. So the NRV for S, and this time it's D, but D is the finished. And this is basically the raw, right? Put down the word raw beside it. And then the third one is the post. So the number of units is 75,000. But remember this one, the number of units, we lost 10%, didn't we? So it's 4,500 units. Now, what's the actual selling price? The selling price for this one is the same as the one above, and same as this one too. But this one goes up to $100, right? $600,000. 4,500 times 100. Okay, so let's do that math. That is 450,000. But remember, we have a processing cost of 100. So the sales value, the NRV value is going to be, I'm going to put a little star beside that one. It's going to be 4,500 times $100 minus 100,000 processing gives us 350. Put a star beside that, okay? And this will be 400. Same as that one. And we're going to do the relative weighting again. This is 44.445%, 25.9259%, and 29.6296%. So the joint cost of $1 million will be allocated based on these percentages. 259, 259. This is 296. 296 is a million. Okay? So the difference between this and this is the sales value of the split off. So what is the value if we were to sell it as is? Now, in my previous video, there wasn't another process further. So the sales value and the NRV would be the same in that case. But in this case, it would be different because of the raw decorative pieces. We could process it further for 100,000 to get a finished goods. So the NRV would be looking at this plus that and this. Now, let's do the physical method while we're at it. So let me put, highlight and let me highlight this one. This calculation is really this one here. For the physical method, we've got studs, decorative, and post. And we know that the number of units, this is physical, number of units is 75,000, 5,000, and 20,000. And we're going to have the relative weighting. So 75%, 5%, and 20%. And we're going to take the joint cost of $1 million, allocate it. So we've got 750,000, 50,000, and 200,000. That would be the physical method. So I'm just going to highlight this, the physical, the NRV, and the sales value at a split off point. So that was part one of the question. Now part two says, prepare an analysis for SSI that compares processing the decorative pieces further as they currently do with selling them as a rough cut product immediately at the split off. So they want us to compare whether it makes sense to process it further or not. And that's typically what companies would need to decide, isn't it? They got to figure out whether it makes sense to sell it as raw or to finish it as a fully finished decorative piece. Okay, so first of all, let's determine the number of units. So we know the number of units is 5,000. And we've got less normal shrinkage. And that would be what, 10%, wasn't it? So we know that's 4,500 our number of units available for sale. And we know that these ones are $100 each. So the revenue is $450. The incremental revenue is $450 less the revenue at split off. And what was the revenue of split off? It was 300,000, right? We did that in part one, didn't we? So it would be 5,000 times 60. So the incremental revenue is 150. What are my incremental costs? So my incremental cost, if you think about what was my incremental cost, it's 100,000. Because this is not relevant, because irrespective of whether we process it further or not, we're going to incur that cost anyway. So the only incremental cost is the processing it further. So additional contribution margin of 50,000. So the answer is it does make sense to process it further, because by doing so allows us to increase our contribution margin by an extra 50,000. Now, part 3 says, assume that SSI announced that in 6 months it will sell the unfinished decorative pieces at the sell-off point due to increasing competitive pressures. In other words, you're not going to process it further. Identify at least 3 types of likely behavior that will be demonstrated by skilled labor in the planning and sizing process resulting in this announcement. So in other words, what's the impact for the folks that are processing this further? So all the skilled labor that's associated with this 100,000 processing cost further, what's the impact to them? And then include in your discussion how this behavior could be influenced by management. So for number 3, when they make that announcement, it's going to obviously decrease morale. Okay. Decrease motivation and decrease job security. So if you think about it, if they make that announcement, it's going to create these issues within the organization. And all of these will lead to productivity issue. Because remember, this is still going on over 6 months. So they're still, again, they're making the announcement today. It's not going to happen in 6 months. What's going to happen is people that are in that particular department are going to be a little bit worried about, they're going to have decreased morale, they're going to have decreased motivation, they're going to have no job security. And again, people that are highly skilled are going to start looking for a job. They're going to leave before the 6 months. And what happens is it creates really a quality issue here. Now, the other piece that we haven't looked at is, what about these other departments, right? These guys here, there's another set of labor that's going to hear about what's happening. They may get worried about their job too. So we're going to probably lose good quality people. So good, skilled workers will leave before 6 months. Now, the second part of the question, how do management combat this behavior? How do management try to improve the morale? So management can increase communication. So let them know that we can perhaps relocate or transfer skilled employees to other department. You could perhaps offer staying bonus. So what are they? Basically, we say to these folks that are in processing these decorative pieces, these raw to finished decorative pieces, assuming they're talented people, and it's difficult to replace them within the 6 months, then we say to them, if you stay within 6 months, we will give you a bonus for staying. And of course, by having a staying bonus will increase quality and productivity. Okay, so that is how management can combat these issues. But in the analysis in part 2, clearly it makes sense to continue to process it further because it's going to generate an additional $50,000 contribution margin. Okay? Thank you.